Right, hello folks. Welcome to the next video. I don't know why it's called number 1. It's obviously number 2. So this video is all about using the gsolve function on your graphical calculators. Okay, so those of you who've joined me for the first video, the basics video, will know that I've already inputted a load of functions here. So 2x plus 5, x squared minus 4x minus 26. I'm actually going to go back and change that one to what it was originally. So it was x squared and minus x minus 6. So we're going to look at these functions, different types, and we're going to look as to how we can use the gsolve function to do these things on the left-hand side here. So these things include finding the roots, any maxima or minima of any curves, the y-intercepts, usually just one. Any intersection points, so we can use it to find intersection points of two graphs. We can only plot two at the same time and use that function, but it is possible to do that. We can also calculate y coordinates given certain x values. We can calculate x coordinates given certain y values, and we're also able to use the integral function to find an integral between two limits. Okay. Now, what I would say on the note of the integration is you're probably better. You can probably see me just in the corner. You're probably better off using this one, okay, and specifically the integration button here to, no, sorry, that's wrong. It's this button here to do integrals. However, it is possible to do it on the graphical calculator, so I wanted to show you that as well. So, as you can see here, at the moment, I've only got one of these selected, okay, so I've just got the 2x plus 5 selected. So let's draw that. Looks pretty good. It's quite spread out though, so I'll just go to V window and just go standard. I should bring it in a bit. There we go. So there's only really two things we want to find here. We just want to find the root and the intercept. So dead easy. Once you've drawn the graph, you just click gsolve root, and that will tell you minus 2.5, and then gsolve intercept, y-intercept, and that'll tell you 5. Okay, so obviously for that one you'll be able to work that out very easy algebraically, but it will just confirm what you already know, hopefully. Okay, so let's deselect that one, and then let's have a go at the quadratic one now. So I've just so you can see, guys, just to make this super clear. Oh, what's happened there? Managed to move 2 bits. There we go. Don't quite know what I did there. Yeah, so I've only selected the second one there, just a quadratic. So I'm going to draw that, and there it is. Looks good. So what can we do for this one? Well, same again. We can find the roots. So root minus 2. Obviously, on this one, you can see there's 2 roots. So if you want the second one, you simply use the arrow button to move along to the second one. So it tells you the roots are minus 2 and 3. And then we could find the y-intercept as well. So gsolve y-intercept. So that's at minus 6. Another thing you want to do with this one potentially that you can't do with the linear graph is to find the minimum point. So you just simply go gsolve and click min. So it tells you 0.5 minus 6.25. If I try to find the maximum point, so if I go gsolve maximum, it just won't do it for you. Okay, I'll say not found, because clearly a quadratic of this form does not have a maximum point, it has a minimum point. All right, but of course there will be curves, such as the next one I'm going to look at, that have both maximum and minimum point, i.e. a cubic. It would be an example of that. So let's go back again, and this time we're going to deselect the quadratic and select the cubic, which is the 4th one in my list. So execute or draw. That looks pretty good. I might want to zoom in a bit there. So let's click zoom in, execute. Pretty good. Zoom in, execute. Oh, that's perfect, yeah? So we've zoomed all the way in. So same again. So gsolve root. So the first root is at minus 1. The second root is at 1. And the third root is at 2. Y-intercept, so we can also just navigate around here. So if I click exit here and draw it again, obviously, so I could just move it up a bit if I wanted to. Yeah, so I can use this arrow button to move it up and down, or left and right. So that looks pretty good. So let's find the intercept now. So gsolve y-intercept, so that's at 2. Okay. What else can we do? Well, we can also do the maximum. So gsolve maximum. So that's at minus 0.215, blah, blah, blah. And the y coordinate of that is 2.11, blah, blah, blah. And again, G-solve minimum, minus 1.54858, etc. Minus 0.6311, etc. Okay, so we're slowly building up and doing more and more. What other function have I got here? So I've also got an exponential graph. So let's have a little look at that one and what we can do with that one. So there's our exponential graph. That looks pretty good. So again, we could do G-solve minimum. Well, there is no minimum for that. We could go G-solve y-intercept. That tells us minus 0.864. I think that's root 3, by the way. No, it's not. It's root 3 over 2, I think. I should check that on this one. Root 3. Oh, root 3 divided by 2. Yes, it is. Oh, no, it isn't actually. It's similar to root 3. Yeah, not quite. Root 3 is 0.866025. I'm just looking at the calculator if you're very impressed by that. So what else can we do? So we could do the y-intercept. We could also do the root. So root, there we go. So the root's 1. Okay. So that's, again, functions that aren't trig functions. So exponential functions, quadratic functions, cubic functions, etc. You can go into quartics, all sorts of things, okay? So you wouldn't want to do it using this, but this is just to check that what you've done is correct, hopefully, for most of it, all right? It might get, for some questions, you are expected to use these things. So let's have a look at the trig one to start with then. So select, actually, let's not do that. So before we do that, we'll look at if we do 2 at once, okay? So let's say we've drawn 2x plus 5, and we've drawn the quadratic. So the scale's no good. So V window standard. Let's see what that looks like. That's pretty good. Although I might want to go higher on the y's. So V window, and let's get y up to 20. See what that looks like. There we go. Okay, so I can see everything there. So what you could then do is also find the intersection points of these two graphs. So I could go G-solve intersect ISCT. So that tells me that they intersect at minus 2.14, 0.71. Okay. And I can move along and it will tell me the point of intersection of this one. Okay, so it's simply G-solve ISCT, which stands for intersection. Okay, and I could do that also. So if I go back, I could look at where the, so let's deselect that one. I can look at where the linear one that I've got there intersects with the what's it called? The cubic, yeah. So you can see there it only intersects once, yeah. So it can be particularly useful because you wouldn't necessarily know if this carried on high enough up here to give you another intersection point around here, but it doesn't. So G-solve intersection, there's only one. And if you try and move around from that, if you try and go right, well, it won't do it. If you try and go left, it won't do it. So you know there's just one point of intersection for those two particular graphs. Okay, so I've covered here so far root, max, min, y-intercept, and intersection point. There's two other things which are y-cal and x-cal. Now you'll notice if you select here, they don't come up as options. So you've got root, max, min, y-intercept, intersect, but then there's an option to go right. So if you click this button, it will move right, and then you've got three more options there. So for y-cal, x-cal, and an integral. Okay. So what this will do. So let's just go with the easiest one. So let's just go with the linear graph. So draw that one. So what I can do is I can calculate x or y values given the other value. So if I go G-solve y calculate. So let's say I want to find y when x is 5. So I'm going to put in 5. So that tells me the x is 5, y is 15. Obviously very easy with this one. So 2 times 5 is 10, add 5 is 15. So that's one way of calculating if you're given the x coordinate, and similarly you can do the same with if you're with x-cal. So G-solve x-cal. So let's say you want to find x when y is 25. Okay. Now that has actually gone off of the grid. Okay, so that's up here somewhere. So I could adjust my scale. I could go V window and maybe go up to 30. Looks like 30 might do it. I don't need to see it, obviously. But what you will notice is even if it hasn't been able to, so I have to do it again. So gsolve xcal, and it was when it was, what did I say, 20, I think. There we go. So it wasn't 20, but that doesn't matter. So it's 20, 7.5. Yeah. So if you did 20 take away 5, you get 15. Divide by 2 is 7.5. So you can use it to calculate given values. Now you can imagine, obviously, for that one, it's very easy because it's a linear graph. You can do most of that in your head. But of course, you know, cubic might be harder. So let's say we plotted our cubic. It's pretty good. Let's do a little zoom. Let's move down a bit. There we go. And then zoom in. There we go. And then move it right a bit and down a bit. Okay, so that looks pretty good. All right. So let's say I wanted to find, I don't know, so gsolve, I want to find the y value when x is 7. No, it doesn't like that. Why doesn't it like that then? Might be that my scale is no good. Let's delete this and try another one. Let's try 3. Argument error. Interesting. X. Oh, hang on, something wrong here. So draw. Hang on. Draw. Gsolve. Y calculate. So enter the x value. So x is 2. So when x is 2, y is 0. We can see that. Gsolve. Y calculate. Let's say x is 5. So it doesn't like it. Okay, so it looks like it doesn't like it because it's off the scale on this one. So let's try and adjust the scale. So let's go V Windows Standard. See what that looks like. Okay, and we're going to go gsolve y calculate. X is 5. We'll try that one. There we go. So x is 5, y is 72. So most things will get sorted out if the V window is correct. Okay, so most things will get sorted out if the V window is correct. So the final thing we can do, and it's a really good one to use this one actually, is we can then integrate between two given limits. Okay, so let's zoom in a little bit. Let's go between. In fact, let's literally zoom in. So zoom in, execute. Okay, pretty good. So let's say we want to find the area here, the area above the graph. Okay, well I know the limits for that are -1 and 1. So I would go gsolve, integrate. My lower limit is -1, execute. My upper limit is 1, execute. So that then, it shades it in for me, and it tells me the area of that particular bit is 2.6 recurring. Okay, so that area is 2.6 recurring. Let's go again. So let's go gsolve. Let's find this little bit now. So let's do between 1 and 2. So gsolve, integrate 1. That's our lower bound. 1, execute. 2, execute. Okay. Now it's done 2 bits there, so I probably want to go out and start this afresh actually. So gsolve. I've still shaded it from the previous bit annoyingly. So sorry, gsolve, integrate between 1 and 2. So that tells us this little bit in here. It tells us it's negative because it's below the x-axis. We'd expect that. That's 5/12. So this has an area of 5/12. So you could then add those 2 bits together, and you would have the total area between -1, say, and 2. Okay. So you might need to obviously pause and go back over and have a little play yourselves, but this should at least give you a prompt of where to begin. So I will go through solving trig graphs a little bit more in another video. So let's have a look at our trig graph though. So our trig graph looks like this. So no good. So let's go V window standard. Don't want standard, we want trig. So V window trig. And whatever comes up here, this will tell you if it's in degrees or radians. So this has come up between -540 and 540. So that's come up in degrees rather than radians. Okay. We looked at this one earlier. So it's not quite a good scale. So we want to go V window. We might want to do between 0 and 360. and it looks like y wants to be a bit lower. So let's make that -5 and see what we look like. There we go. That's pretty good. So we could then do, and I'll quickly mention it here. So let's say you wanted to solve this graph where it was equal to -1. So I'll pop in -1 there. So exit. So you can see there it's got 1, 2, 3, 4, 5. This one might just be in the range, 6 intersection points. And if we then want to find those, we just go gsolve intersection. So it intersects at 0, -1, 60, -1, 120, -1, 180, -1, etc. Okay. And once you get to the end, you keep trying to go, it won't let you. Okay. So it won't let you go beyond that point. Similarly, if I go back to here, it won't let you go beyond that point either. Okay, so hopefully that has been useful and given you an idea. It really is quite straightforward. I mean, I knew nothing about this a few years ago, and I can do lots of basic things on here. And these are all things that are going to be reassuring for you to check in your exam. So you do the question, you check it on your calculator, you know you've got the marks, you haven't got to then go back and check it later on. Okay, it's a really nice way of making up your own questions as well for practice, obviously. So if you want to make up some trig questions, solving trig equations, you could just set them up, put them in here, try solving them, check that the graphical calculator says the same thing. Okay, so in my next video, I will start talking about solving, using these to solve trig equations specifically, and I'll also be looking to produce a couple of videos on using them for modulus graphs as well. Okay, but obviously I can produce any that you think will be helpful. Right then, folks, thanks for that. And I will see lots of you very soon, I hope.